Assalamu alaikum. In the last video, we have obtained the expression for radius of the orbit in which electron revolve. Apart from that, we also obtained the expression for velocity of the electron revolving in that particular orbit. In this video, we'll get the expression for energy of electron in the nth orbit of an atom. For this, I start with the diagram of an atom. According to Niels Bohr, in an atom, electrons are revolving in a circular orbit in the clockwise direction around a positively charged nucleus. This is the structure of an atom according to Niels Bohr. Here, the distance from the center of the nucleus to the orbit is referred as radius of that particular orbit. And here, the tangent drawn to the orbit gives us the velocity of the electron in that particular orbit. Here I have taken this orbit as nth orbit. So while writing V and R, I have written N beside it, which represents the velocity of electron in nth orbit, and here this represents the radius of the orbit, radius of the nth orbit. Okay. So here the energy possessed by an electron revolving in an orbit is found to be the sum of potential energy and the kinetic energy of that particular electron. Okay, so I told you here the total energy possessed by the electron is the sum of potential energy and kinetic energy. Now first I'll write the expression for potential energy, then I'll write the expression for kinetic energy. Then I'm going to add them together to get the total energy possessed by the electron. Okay. Here, potential energy of the electron is represented by letter U N. So potential energy of the electron in the nth orbit. And now we know very well potential energy is the mgh. Okay, by keeping this in mind, I am going to derive the expression for potential energy for a given electron in an atom. Okay, here before doing so, I am going to modify this equation according to the case. Okay, here instead of g, I write the a. Is acceleration, okay, with which electrons are revolving around the nucleus. Here m is the mass of the electron and h is height here, whereas in our case, in the place of h I take the distance between the orbit and the nucleus. There is nothing but Rn. Okay, so here g is replaced with a and h is replaced with the Rn. So if we do so, we obtain this equation, which represents the potential energy. Okay. If it is so, here MA, actually, according to Newton's second law, product of mass and acceleration gives us force. The force that acts here between the nucleus and electron is nothing but Coulomb's force. Is this Coulomb's force? Now what is this Coulomb's force? Coulomb's force as 1 upon 4 pi epsilon naught, the product of Q1, Q2 upon R square. Here Q1 is the charge of one object, Q2 is the charge of another object. Okay, in our case, I take the charge of nucleus. Here is nucleus is taken as one object. Its charge is plus Q plus ZE, and the charge of the electron is minus E. Okay, the star multiplied, and here we have 4 pi epsilon naught. And in the place of R, we have Rn square. This is the Coulomb's force acting between nucleus and the electron. Now from this, if we multiply this with the Rn, I'll get a potential energy from this equation. So potential energy is obtained if I multiply Coulomb's force with the Rn. So if I do so, minus sign Ze square. If I multiply these two, divided by 4 pi epsilon naught Rn square. It is multiplied with Rn here. If I do so, this Rn and this get cancelled, and what remain is nothing but this minus Ze square upon 4 pi epsilon naught Rn. This is the expression for potential energy possessed by the electron revolving around the nucleus. I take this as equation number 1. Now I'll get the expression for kinetic energy. Here electrons are in motion. So any object which is in motion possesses some energy. We call that energy as kinetic energy. So the kinetic energy possessed by electron. Kinetic energy possessed by the electron is given by this equation, half mvn square. Now here I am going to substitute the value of this term. So for that I am going to follow the method that I have followed earlier in the previous topic. I take this as the equation number 2. Now we know the modulus of Coulomb's force is found to be equal to the modulus of centripetal force. So what is that? Here the modulus of Coulomb's force is this, Z E square 4 pi epsilon naught Rn square is equal to centripetal force is this mvn square upon Rn. Okay. What is my aim here? My aim is to get the value of mvn square. So the similar terms both sides it cancel. And what remains is nothing but mvn square. So I write this here. mvn square is equal to Ze square upon 4 pi epsilon naught multiplied with Rn. Okay. This is taken as equation number 3. Now I substitute 3 in 2 to get the kinetic energy possessed by the electron. 3 in 2. So what I'll get if I do so? The kinetic energy will become equal to half multiplied with this value, Ze square divided by 4 pi epsilon naught multiplied with Rn. Okay, if I multiply this two, then the value of a kinetic energy will be 1 here 2 is multiplied with 4. Here 8 pi epsilon naught Rn, and in the numerator we have z multiplied with e square. This is taken as equation number 4. Equation number 4 gives us the kinetic energy of electron. Now if you compare equation number 1 and 4, you may find both appear almost the same, but only one difference is here we have negative sign, here we do not have negative sign. In the denominator we have 4, whereas here we have 8. Okay. So now from equation number 1 and 4, we can obtain the total energy. Total energy of electron is obtained by adding these two. First, I'll substitute the value of potential energy. What is that? Z square minus 4 pi epsilon naught Rn plus the value of kinetic energy, Z square upon 8 pi epsilon naught Rn. So here I represent total energy of electron by letter E. Okay, and N stands for nth orbit. So En is equal to. Now I'll take the common term outside. What is the common term here in both? The common term is Ze square. 4 is present in both. So 4 pi epsilon naught Rn. By taking out this, what remains is nothing but this. Yeah. Minus 1 plus half. This is what remains here. I hope it is understandable. Okay. The next, if you subtract this two, what you obtain is nothing but minus a half. Okay. So minus half is multiplied with this, and we obtain En value as minus, this minus is written here in the front, Ze square upon this half, this 2 is multiplied with 4, 8 pi epsilon naught Rn. Okay, this is the final expression which represents the energy of electron revolving in nth orbit. I take this as equation number 5. Okay. Now in equation number 5, if I substitute the value of E pi epsilon naught, then the value of En obtained, something like that. Okay. And before doing so, I am going to substitute the value of Rn here. Okay. Here Rn is radius of nth orbit. That I am going to substitute. We know from the previous topic, Rn is nothing but epsilon naught h square upon pi m e square multiplied with n square upon z. This is the expression for radius of nth orbit. No, that we have derived in the previous topic. Okay. Now this I take as equation number 6. Now I'll substitute this in 5. Substituting 6 in 5. What I'll get if I do so? I obtain this. En equals to Ze square upon 8 pi epsilon naught. Then here I have Rn in the denominator. So should take the reciprocal of this term. So what is that? Pi m e square. Whatever is present in the denominator is taken to the numerator. by taking the reciprocal. Okay, then the terms present in numerator is brought to denominator. Okay, now here pi and pi will cancel. That's all. There is nothing to cancel in this equation. Then I simplify this equation and write here En equals to z multiplied with z gives us z square e square gives us e power 4. Then m remains here as such, divided by the z square m e power 4. Okay, and here I have 8. Okay, then epsilon naught multiplied together to give us epsilon naught square, then h square n square. Here I have forgot to mention the negative sign. I do here. Okay, it's very important. Negative sign. So this is the final expression which gives us energy of electron in nth orbit. Okay, I'll box this and then name this one as equation number 7. Okay, here Z stands for atomic number of the given atom. Suppose I take hydrogen atom. For hydrogen atom, which stands for hydrogen atom is equals to 1. So equation 7 takes a new form. So En becomes equal to, here in the place of Z I take a 1. So negative sign, e power 4 m divided by 8 epsilon naught square h square n square. This is the energy of electron in the nth orbit present in hydrogen atom. Okay, now I name this equation as equation number 8. In equation number 8, if I substitute the value of E, M, epsilon naught and H, what do I get? Okay, before substituting the values, let me tell you what these things represent. Here, E stands for charge of the electron, M stands for mass of the electron, epsilon naught stands for permittivity of free space, and H stands for Planck's constant, and N represents a principal quantum number. Okay, and this is a variable. Except these values, N is a variable. Except N, other values are constant here in this equation. So on substituting the values of E, M, epsilon naught and H, we obtain this equation. What is that? En equals to minus is as such 13.6 divided by n square. Okay, and this energy is measured in electron volt. Here 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Okay, so this is the energy. Now suppose there is an electron present in the first orbit, then in such case N is taken as 1. When n is taken as 1, then En will become E1. Then the value we get is minus 13.6. Here in the place of n I take 1. So denominator will vanish. And what I obtain is this. So energy of the electron in the first orbit is nothing but minus 13.6 electron volt. If an electron is present in the second orbit, then principal quantum number is taken as 2. Then En will become E2. Then the other equation 13.6 multiplied with 1 upon 2 square. 1 upon 2 square. There's nothing but 4. Okay. 1 upon 4. This electron volt. Then this is equal to minus 3.4 electron volt. In the similar way, the electron present in the third orbit possesses energy equal to E3. Here E3 is equal to minus 1.51 electron volt. And I told you here 1 electron volt is equal to 1.6 into 10 power minus 19 joule. Here joule is the unit of measuring energy. 1 electron volt is also an unit of energy. It's the smallest unit of measuring energy. Okay, and if you observe this clearly, you may find that as we go away from the nucleus, the energy of the electron increases. But from the number, if you see, earlier it was 30.6, the second it has reduced to minus 3.4, then it has become minus 1.51. Number wise, it seems to be reducing, but beside the number we have negative sign. If we have a number with a negative sign, in such case, as we reduce the number, it means the value is increasing. This is what it means. For example, let me tell you, minus 9 is greater than minus 90. Okay, so minus 13.6 electron volt is lesser than minus 1.51 electron volt. Clear? So this shows that as we go away, the energy of electron increases. Clear? That's all about it. So from this we can conclude that the energy of the electron present in ground state is lesser than that of excited states. Fine. And before I conclude, let me provide some more information about this. Here, minus 13.6 electron volt is the energy of electron present in the ground state of an atom. Okay, ground state of a hydrogen atom. This is taken as a unit for measuring energy, and we call it as Rydberg constant. We call this value as Rydberg constant. And here 1 Rydberg is equal to minus 13.6 electron volt. There's no space here. Okay, let me write it here. Here 1 Rydberg is nothing but minus 13.6 electron volt. This is the smallest unit of measuring energy. Okay, I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put your questions in the comment section. Thanks for watching.